Hello everyone, welcome to my Bricks model channel. On this channel I build models and showcase what we can do on the Bricks model platform. Today I thought I would build a water molecule, or more specifically some hydrogen molecules reacting with oxygen molecules to form water. So let's get started. I'm going to start off with picking an item from the shape set. Let's take a sphere and we'll put that onto the work surface. This can represent our hydrogen atom. When you model molecules and atoms, they usually have specific colors so that people can immediately recognize which one it is. So hydrogen is usually modeled as white. So we will select this object and let's just give it a light color of white. How's that look? That's white. Okay. Now, when hydrogen is in its free form, it usually combines with another hydrogen molecule. They share electron and form a diatomic molecule. So we'll select this object and we'll copy that. Okay. Now we've got two. Great. And then they'll combine together to create a molecule. So let's just position these things in a good spot so that they're combined. We'll put the first one, say, somewhere around there. That looks good. And we'll put this one maybe somewhere around here. If I key in the properties, I can set the position exactly where I want it. Okay, there we go. And if I hold down Shift, I can actually select both of them. And when this reaction occurs, you actually need two of these hydrogen molecules. So we'll copy this. And there we've got two more. And we'll just move that to our position where we can let them sit for the time being. Maybe somewhere around there. Maybe somewhere around there. Does that look okay? That looks pretty good. Yep. So, if we're going to have this reaction, we're going to need some oxygen. So let's get some oxygen. We'll get another sphere and we'll make this one red, because if we have a look at an example of a model, like let's pull one up here. There's a carbon dioxide molecule, and you can see the carbon's in black. That's a standard for carbon, and the oxygen is in red. So we will make our oxygen red as well. So take our oxygen atom, and we'll pull up this color selector. There. Now we've got our red atom. Oxygen also forms a diatomic molecule with another oxygen atom. That's the O2 that you'll see in the formula. We'll just copy this. So there's our second oxygen atom, and we'll just place these in a good position. Okay, something like that, and here we'll make this maybe something like that. Now, also, these oxygen atoms are bigger. They have a higher atomic mass than the hydrogen. They're about twice as big. They're usually represented as twice as big. So let's make these bigger. Make it all bigger on all three dimensions, X, Y, and Z. Okay. Now it's looking like a oxygen molecule. Okay. I like that. Now, for the reaction. the reaction part. This is the where things happen. To make things happen, to ignite the reaction, we're going to need a switch. So we'll just turn a switch on here, a little toggle switch. That'll be good. And what that means is when we flip the switch, energy will be added and the reaction will occur. That means the atoms will separate from their bonds. They'll go to a lower energy level by recombining and releasing that energy, and the electron sharing arrangement will be different. So we'll just set the new positions for our atoms as once they're free. This one here is going to move something like, we'll set the motion travel at 1. I kind of already played with this, so I kind of know what I'm looking for. And we'll set this, well, let's try out the first one. We'll assign the switch. It's TG1 for toggle 1. And we've given it some travel. So this atom should move when we flip the switch. And it is. It's a bit difficult to see, but we'll fix the colors, contrast up here in a minute. You can see it moving. Okay, and then the other one is also going to move. That's going to travel about this amount. Okay. Alrighty. Let's have a look at that again. Okay. We've got some action going on here. This molecule, this atom, does not have a switch assigned TG1. Okay. That will also adjust our oxygen motion. -1, 0, -2. That should do it. Okay, we assign toggle to the oxygen. Starting to get some action here. Let's just, okay. These atoms need some motion assignments, so we'll give them what they need. And assign TG1 to that atom. Let's assign TG1 to this atom. And for some motion, we'll go let's see how that looks. Something's not right. I think this needs to move in the X direction more. Okay, let's try that. Unselect it so it looks better. Okay, I'm liking that. We got a reaction going on. So what we can do now is let's add in some text to show the reaction. So we've got basically 2 H's. I don't like that color. Let's make that something more like a yellow. Yeah, that looks good. We got 2 H's, and then we got an H2, so that's a subscript, so we'll put a number 2 down here. Okay, and we want that to be the same. We want that to be yellow as well. And I'm going to make that half the size, so it's 0.6. 6.5. Okay, there's our two H2s. Maybe give it a little. No, we don't need any space in there. Let's just go 2H2. And we'll just copy this and change the text. What is it? Plus an O and plus a 2. So we'll copy this. 2H2s plus, it's actually a single O2, that's right. Okay. Let's we'll group those together so it's now one label. And what we can do is we can write down the second part of the reaction, which is 2 H2Os. So I'll just ungroup this and we'll go and just call this an O. And we don't need that, we'll delete that. There's our 2 H2Os. And we'll put those back in as one object. Group them together. And let's just finish this up by making it disappear and appear as part of the model. So we'll set the transparency. The off transparency will be 100 and the on transparency will be 0. So that should disappear when we flip the switch now. As long as we assign the switch TG1. Does that work? Ah, there we go. And then we can do the same thing with this one, but we'll do it in reverse so that it's not visible at the first part, but it is on the second part of the reaction. Okay. We also need to give this a TG1. Okay. There we go. And I'll just move this over here. I think we've got it. Maybe I should raise it up a little bit. Let's raise it up along the y-axis a little bit. We'll put it at position 1. And we'll put this on the y at 1. Two H2s plus an O2. Bang, the reaction occurs and we got 2 H2Os. So, just a couple of little things to polish this up. Why don't we set the background color to make it a little more striking. We'll select an image here. Let's just select a stock image. Subscribers can upload their own images, but we'll just select a stock image here. Here, astronomy. Looks good. We'll set that as the background. There, we kind of got sort of a spacey thing going on, science kind of vibe. I like that. And we don't really need the grid anymore. We can turn the grid off. And why don't we hide the surface? It's still there, but it's hidden. So now we kind of got, ooh, that's nice. That's nice. I like that. Let's just see. We've got our reaction occurring. Okay. So what we've done is created a pretty standard model of this reaction. It's It's a combustion reaction that releases energy, and the hydrogen molecules are combined with the oxygen. We get an oxidation reaction, and it can release energy. These colors, I think I'm pretty happy with them. What you can do is build your own model, look around and see what you want. I've got some examples here I can show you. This is a space-filled model. You can also do ball and stick as another standard type of model. The ball and stick model looks something like that. That's quite common. Neither of them are right or wrong. They're just different representations of what's happening that shows the space by which the electrons, nucleus, protons, and everything occupy the space. So that's a ball and stick model. You can also do a space-filled model that would look something like that. That's what we've just done. And again, you can see the colors clearly tell you what it is. You know right away. Then the advantage of building the model here in a virtual form is you can really be in control of the colors, all of the details. There's no limit to what you can do to enhance this thing. Like if you look at a physical model, something like something like that. That's an image of a physical model. That looks pretty good, and you can actually pick it up and hold it. But you can't modify it. You can't change the angles other than the predefined setup that it's given you. So by making a virtual model here, you can put the atoms at different angles and make it exactly the way you want it. Change the colors and make it customized. Another complicated model would be that one. Obviously, if you don't have the pieces to make a physical model, then that's going to limit what you can do. If you want to build a complicated model, you got to have a lot of parts if you're actually going to physically model it. So that's good. And then the other advantage with doing it on bricks model is you can do a really complicated model or a very colorful model. For example, another one I can show you is sodium chloride. That's a lattice type structure. That's quite pretty. I'd like to model that one. Maybe we'll do that someday. But in the meantime, we'll just enjoy this. What I think I will do as one last step is I'll give it a nameplate. Every good model needs a nameplate. So we'll give it an info box here and a title. For the title, why don't we just call it the hydrogen-oxygen reaction. And for a description, we'll just say something like hydrogen combustion the hydrogen molecule is the bonds between two hydrogen and two oxygen atoms are combined to what are we going to do here? Okay, something like that. And when you show off your model, you can get a link so that someone can play with your model and modify it and change it. Share the link, take a picture of it if you want and share that. And just close that out and we'll try it one more time. Very nice. I like that. Thank you for watching. It's been fun. I will put a link to this model up on the show notes, and you can work with it, or I'm sure you've got other ideas. You've probably thought of all sorts of ways you can make this better or do something completely different, and that would be fantastic too. Thanks for watching. Please like and share this video, and we'll see you next time. Bye.